lines in our homework over the weekend was because this is the polynomial chapter. Linear is an x to the first polynomial. X squared is a polynomial of degree 2. And these are things that they expect you to know, but we're reviewing them. For instance, well, first of all, I said we're not going to complete the square until chapter 8. And actually, chapter 8, parabolas are going to come back, but we're going to have parabolas that also go right and left. That'll be a difference, something different that you'll see. But for right now, if I need to find the vertex to describe the graph of each function, really should be worded a little bit better. We want to put this in this format. I did not complete the square yet, so we are not going to cover that. We're going to try to synthesize our ideas when we need them, not spread your brain out in these times that we live in. Before I do this, what is A? What is A for this one? 3, 2, 1, go. Repeat that person. 5. All right, so I'm putting it in this format. A is A. This will not change because A is 5 over here. So instead of completing the square, you could do this. Okay, what's the formula we got to remember for this finding the vertex? Got an A, B, and or a C in it. 3, 2, 1, go. Over 2A. Thank you. I appreciate those that said that. Everyone else that didn't say it, maybe you're just being lazy or you're behind. That's right. I'm going to say it because that is your job. You need to know that that is how you find this. All right. Oh, no. So the opposite of 25 over 2 times 5. Darn it. I have a fraction, which is 5 halves. I'm going to leave it like that. And I know that because 5 goes into 25 5 times. So 5 halves. I'm going to leave it and evaluate what the, so what do I have right now? Before I evaluate, I have x minus 5 halves. That's where it goes in the formula. All right. The toggle between intercept form and vertex form. And then plugging this in, 5 halves squared, not a big deal, 25 fourths, minus, oh boy, this is going to be big, 25 times 5 halves, plus 12. The pen doesn't write. All right, this is 25 fourths times 5, which is 125 fourths. I'm trying to speed this up. Okay, so 5 squared is 25, 2 squared is 4. Then 25 fourths times 5 is 5 times 25 up on the top. That's how you multiply fractions. So I did multiply after. I squared first, then I multiplied. This is negative 150 halves. I'm going to be a bum and write that up here for this because it's 5 times, that's not right. What's 5 quarters? I was never good at math. How much is 5 quarters? A buck what? 25. Oh my goodness. It is Monday. I guess I could use that as an excuse. But then I need a common denominator, which is negative 250 fourths. Double the numerator, double the denominator. Oh, then 12 is 48 fourths. 4 times 12 is 48. All right. Now I'd probably use a calculator because this is annoying, but negative 125, is that negative 102 fourths? Is that right? Negative 102 fourths? Wasting a lot of time on fractions, but that's okay. I know 2 goes into both of these. 51, so negative 51 halves. I hope that's right. Anyone verify? 125 minus 250 plus 48. Anyone? Is that right? Is that right? Are you just saying that just so I can move on? You mentally, what are you doing? You playing like Block Dude? Did you know there's games on there? There's a cool game called Block Dude. Do you have it? You ever play Block Dude? It's fun. It's one of my favorite. Anyway, minus 51 halves. Your newer calculators may not have it pre-installed, so you might have to download it if you want those games. Oh, a bunch of different games. Yeah, I know about that. I'm talking about the old school, like bought the calculator in 2001 and the games were already pre-installed. Fun times. All right, moving on to this one. And we have a lot of these questions when we do chapter 8, when we, but some different things about it too. But this is pretty straightforward. Write the equation for the parabola shown using the fact that one of the given points is the vertex. Since I have the vertex, I should use blank form in order to find this equation. What is the blank? Starts with a V. Vertex. So I have the vertex. So to find this equation that matches this parabola, I should use vertex form. We're doing this in Math 2 honors, or we actually just took our test on this. This being one of the forms. The other one was intercept form, which we are going to deal with that in chapter 2.3 and 2.4 and 2.5 quite a bit. You know, the idea of having x-intercepts for a particular situation. All right, class, what letter does -1 represent in this formula? Hold on. What letter does -1 represent? 3, 2, 1, go. Well, I heard someone sneeze during that. Did you time that on purpose? All right, let's do that one more time. What does -1 represent? 3, 2, 1, go. Oh, I heard a couple different things, but I heard most people say the right answer. That is H and only H. I know it's our X value as well, but it is specifically the vertex's X coordinate. Oh, nobody should miss this one. What's 5? 3, 2, 1, go. Okay. Oh, I heard a couple other different things. I know it's a Y coordinate, but it's the K value. Okay, so then what's the point of this other arbitrary point? What's 2 represent then in our equation? 3, 2, 1, go. What letter is going to be? Y, X, or A? 3, 2, or 1, go. X, it's an X coordinate. So since it's a random X coordinate, I'm allowed to plug it in to the X position of this equation that should match this parabola. Nobody should miss this last one. What's -13? 3, 2, 1, go. Y. Sorry for that dark color, kind of kills that. And then what you're left with is an A value, and that's what you're supposed to be solving for. Sorry. Let me go back. Forgot to write the A. X minus H squared plus K. And then what I was about to yell is, even when we get this far and I got seniors that can't solve this. Blah! You want to know why? They are violators of PEMDAS. Really, order of operations, even in solving, come into play. Oh my gosh, my pen is acting like a big jerk. Won't write, and I have to write a letter 5 times before it actually writes. Okay, the very first thing is, what's P stand for, everyone? What's P stand for? Parentheses. So I got to do 2 minus -1, which is 3. What's E stand for? Exponents. What's 3 squared, everybody? And then I still get seniors that miss this. Actually, in sophomores. Then they do all this, and then they start doing crazy stuff like taking 9 minus 5. Should I take 9 minus 5 on the right side? Yes or no? Someone's shaking their head yes. Huh? What? Where? What? I have no idea. Jeez, they're all yelling at me. Okay, sorry. I wasn't done writing. Okay. Okay, do I take 9 plus 5? Yes or no? No! I get people doing this all the time, doing some crazy stuff and solving grade school mistakes. What should I do next to solve? Minus, everyone. -5. Oh. Apparently someone took over the class. All right, and then A equals -2. All right, I hope you heard that on the microphone. Okay, no, that's all good. I appreciate that. All right, yeah, he got it. So, but that's not the final answer. The final answer is bring back the Y, put the A in, and then bring back the vertex. And then why do we have the XY back? Because there's an infinite amount of coordinates. All of these are created by this equation. I know I have that 1, but then there's an infinite amount. But how many vertexes are there for this one parabola? 1. That's why the vertex must come back for the equation. Some people get that A equals -2, then they don't know how to express the final answer. They throw answers with a bunch of numbers, and they don't bring back the equation. I don't know how else to say that. Really feel stupid doing this one, because is this any different than the last one? Yes or no? Just look at it. Is it? Is it? No, instead of having a picture, they physically tell you the information. So therefore, I just physically start plugging in. Here's Y. I'm finding A. Here's X. and then minus the x-coordinate of the vertex, and then plus the y-coordinate of the vertex, but it happens to be a negative. So it's really the same highlighting, I just don't have a picture. Thank you, yeah, all right. What? Okay. All right, so careful on this one though, and I guess I didn't want to go too fast. H, comma, K, and then an arbitrary x and y equals a x minus h squared plus k. Careful on this one. What's negative 4 plus 2? Oh, I've been asking this all year long. You get weird answers. What's the answer? Negative 2, but what's negative 2 squared? 4. So don't be making those silly errors of squaring incorrectly, and do write 4 there. And then add 5. Is that negative 22? Divided by 4, and then you get negative 11 halves. Right? I feel weird on this. Maybe I haven't done this in the past, but that's not the final answer. You bring back the y equals a. You bring back the x, and then it is x plus 2 squared minus 5. That's the equation that matches this data. Oh, I love this next one. Actually, this reminds me of a question in our old Algebra 2 book. And I do want you to write this down as this, and then maybe for confusion's sake, you don't have to worry about something here. But this is true. And then I'm not going to worry about the one to the right. I forgot that this was here, but I like it. Velocity over time equals negative gt plus v sub 0, the initial at any specific time. What speed is the object doing at a particular moment? So I throw a ball up in the air, and I throw it at 100 miles an hour. Ooh, fish playing the major leagues. 1, 2, 3, go. What's the ball start doing immediately as it's going up? Does it speed up or does it slow down? Why? What's making it slow down? Starts with a G. Gravity. And then theoretically, at one point, it's going to stop, right? So at its height, for that instantaneous moment, this is traveling 0 miles per hour, right? Does that make sense? So at first it's 100, then slow down, so it's 0, and then it starts coming down and starts speeding up, all right? So I think that's what that formula is, off to the right. How fast is it going instantaneously at that one moment? I don't really need that one. I like this one. What does G stand for? What does G stand for? What do you think? Gravity. So go back to my Algebra 2 book, not that you care. They had a great question about, hey, if I throw a ball up on Jupiter, Saturn, Mars, and the moon, what's the maximum height it will reach, and at what time will that happen? Well, at Jupiter, first of all, if I went to throw a ball on Jupiter, I'd be crushed immediately into a ball, and I'd be dead, all right, because the gravity is so strong and the pressures are so strong. But the gravities are different on each planet. Mars, it's less than ours. I forgot what the fraction is for that. I know Earth, compared to the moon is 1/6. You ever see the astronaut hit a golf ball on the moon? It's actually kind of crazy. That ball flies and it just goes because the gravity, the ball just keeps going, blah, blah, blah. So here's our gravity on Earth. The constant is negative 32 feet per second. What am I doing? It's right here. All right. So we use that. How many people were in physics? Raise your hand. Physics uses meters per second. So the thing you saw in front of this was negative half of 9.8, which was 4.5 is 9, 4.9, right? Negative 4.9 was in front of there. We will have this formula, S sub t. I don't know why S. It should be H sub t for height over time. Negative 16t squared, because the gravity on Earth is 32 feet per second. For the formula where the object is over time, you'd have to take half of that. Then going back to our Algebra 2 book, it depended about what the gravity of the planet was, what went in front of here, and it was kind of a neat question. Velocity, that's my 100 miles an hour. And then S should be H. I don't know why they use S, but that's the initial height above the ground. So look at me right here. As I throw this ball up, 1, 2, 3, I let it go. I'm about 3 feet above the ground. That matters, where you release the ball from. So that's what S sub 0 is. And yes, you're going to have to know this. And yes, you did do this before. Okay, so you will be responsible for plugging in the numbers in the proper spot. So train 10-year-old players to catch high pop-ups. So ready, set, go, poof, shoots the ball up in the air. All right, the thing is set at 48 feet per second, and the ball is released. I mean, we have a machine, so it's like 3.5 feet high where it shoots out of the machine. So that matters. So the first thing is letter A, what is this equation? Well, you're on Earth. You know what? I'm going to do H sub t because height makes height over time. I'm changing the game. I'm changing this book's dynamics. You're on Earth. So 32 feet per second divided by 2 or negative, because negative it's pulling down on us. It's a directional thing. Negative 16t squared always goes there. But then it was 48 feet per second initially, and we were 3.5 feet high. What is the maximum height of the basketball or baseball that it'll reach? And when will it reach that height? Well, that quite simply, first of all, which way does this parabola go? Up or down? 3, 2, 1, go. Down. So if we were graphing this over time, your ball would start at 3.5, and then over 1 second, 2 seconds, 3, this is the height, and it's going to look like this. Then eventually the ball is going to hit the what? What's the ball going to hit? The ground, and then that's the time that it hits the ground. We'll be able to solve that later on this. So what I want to know is at what time does it reach this maximum height? That's the graphing of this. So I need to understand this is a vertex question. How do I find a vertex? Negative, say it. Negative, say it. Negative, say it. B over 2 times A, and then look at what happens. This is a nice little, I guess that's not the nicest number. You're not sleeping back there, are you, with those glasses? I can't see your eyes. Good. All right, so this ends up being 1632.48. Is this 1.5? What's 1.5? The height that it reaches or the time that it reaches that height? Which one is it? 3, 2, 1, go. Time. Okay, this is the t. This is what t equals when you do the negative b over 2a. This is the x value, but in this case the t, which stands for time. So that's that. And then go ahead and type on your calculator for this, and then I'll be done with the tape. Can someone do this for a fellow? The fellow being me. Now we plug this in an input to get the actual height. So it's really not a hard question. By the way, as you're typing this does not account for what? Air resistance. Anyone in physics knows the answer to this question. What would fall first, a bowling ball or a feather? 1, 2, 3, go.
With air resistance, the bowling ball, but
without air resistance, it'd be what?
It would be a tie.
A tie, correct. Okay, I think they have those videos on YouTube where they show that in vacuum, they drop a bowling ball on a feather, and boof. It's like mind-blowing to see that. It's not like our natural thing that we would see. By the way, what did you get for an answer? 39.5. So in 1.5 seconds, forgot my S. Max height. Caveman this out again, or cave person. 39.5 feet is what it will reach as its maximum height. You increase this feet per second, it'll go higher, blah, 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 blah. All right? So just know that formula. It's a common one. If you were in physics, they did it in probably meters per second. So it was like negative 4.9 t squared out in front of there. But then your speed of initial velocity had to be in meters per second, just a different label. All right, I'm done. Let's stamp away over here, pick my new color.